Hi, I'm Navinjith from 4th semester BSc PFCS.
And I am Devanadh from 4th semester BSc PhCS. We are here to explain the working and theory behind the petrol engine.
Petrol engine. It is an internal combustion engine developed by Otto in 1876. It consists of a cylinder fitted with piston. The cylinder is provided with an inlet and outlet valve. The opening and the closing of these valves are controlled by the motion of the piston. It is a 4-stroke engine and uses 98% air and 2% of petrol vapor mixture as working substance.
The working method for 4-stroke engine is described as follows. The first process is the suction stroke. In this stroke, the inlet valve is opened and the air petrol mixture is sucked into the cylinder by the outward motion of the piston. The second stroke is the compression stroke. In this stroke, both the inlet and outlet valve are closed and the mixture undergoes adiabatic expansion and its volume is reduced to about 1/5 of the original volume. As a result, the temperature of the mixture is raised about 600 degrees Celsius.
Working stroke. During this stroke, both inlet and outlet valves remain closed. Spark is produced at the sparking plug and the compressed mixture of petrol vapor and air ignite. The temperature rises about 2000 degrees Celsius and a pressure of about 15 atmosphere are developed inside the cylinder. The piston is pushed downwards and shaft rotates. Only in this stroke, work is done by the piston.
The exhaust stroke. This stroke is the final phase in a 4-stroke engine. In this phase, the piston moves upwards, squeezing out the gases that were created during the combustion stroke. The gases exit the cylinder through an exhaust valve at the top of the cylinder.
The PV diagram of the ideal Otto cycle is shown here. The diagram models how the change in pressure and volume of the working fluid change due to the combustion of hydrocarbons which power the movement of a piston, creating heat to provide motion for a vehicle. There are expansion, piston motion, caused when the thermal energy is released from combustion, inducing work done by the gas and on the piston. In contrast, when the piston does work on the gas, the engine chamber is being compressed.
The following describes what occurs during each step on the PV diagram, in which the combustion of the working fluid, gasoline, and air changes the motion in the piston. Referred to as the intake phase, the piston is drawn down to the bottom to allow the volume in the chamber to increase so it can intake a fuel air mixture. In terms of thermodynamics, this is referred to as an isobaric process. Process 1 to 2. During this phase, the piston will be drawn up so it can compress the fuel air mixture that entered the chamber. The compression causes the mixture to increase slightly in pressure and temperature. However, no heat is exchanged. In terms of thermodynamics, this is referred to as an adiabatic process. When the cycle reaches point 2, that is when the fuel is met by the spark plug to be ignited. Process 2 to 3. This is where combustion occurs due to ignition of fuel by the spark plug. The combustion of the gas is complete at point 3, which results in a highly pressurized chamber that has a lot of heat. In terms of thermodynamics, this is referred to as an isochoric process. Process 3 to 4. The thermal energy is the chamber as a result of combustion is used to do work on the piston, which pushes the piston down, increases the volume of the chamber. This is also known as the power stroke because it is when the thermal energy is turned into motion to power the machine or vehicle. Process 4 to 1 and exhaust phase. From process 4 to 1, all waste heat is expelled from the engine chamber. As the heat leaves the gas, the molecules lose kinetic energy, causing the decrease in pressure. Then the exhaust phase occurs when the remaining mixture in the chamber is compressed by the piston to be exhausted out without changing the pressure.